The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
This is number 4 of the second test in Physics 2048 from fall 2010, and it states, for a block of mass m to slide without friction up the rise of h shown, it must have a minimum initial speed of what? Okay, so we're looking for V min is equal to what? Alright, the figure that it has that I want you to get used to is always drawing. You always draw in physics. You always draw the figures. If they give you a figure, then you can use it, but I'm not giving a figure on this board, so you always draw it. So the drawing, that's H. You have M coming this way, and then at velocity V, and it goes up this rise of H. Okay, and once again it says for a block of mass M to slide without friction, so there is no force of friction going backwards. There is no force of friction going backwards. It must have a minimum initial speed of what? We're not given any numbers, any information on this at all, okay? So it's going to be relating equations. So we know that we have a height here and a starting velocity here. Okay? How do you think these relate? Most likely dealing with potential and kinetic energies. Okay? It starts out with kinetic energy and it ends up with potential energy. Because if it says it must have a minimum initial speed of what, that means that it comes to a stop when it gets to the height that it wants. So minimum means that it just reaches that height. So at this point, the energy will be only mgh because there is no kinetic energy. It's equal to 0. Okay? Kinetic energy is equal to 0. Alright? So U is equal to mgh for review, and then K is equal to 1/2 mv squared. Alright, so up here we only have mgh. There is no kinetic energy because there is no velocity up here. We're looking for minimum velocity. Alright, so over here we're going to go ahead and assume there is no potential energy because it's at the bottom. So it only has kinetic energy, and that's equal to 1/2 mv squared. Okay? So this doesn't have any, but it has this. This has some, but it doesn't have this. Alright? So now let's go ahead and relate the two, because conservation of energy says that the energy here is going to equal the energy here. So we know that 1/2 mv squared at the bottom is 1/2 mv squared. And it's equal to mgh up top. Alright, so now we see that there's this equation here. You can cross out the m's to make that, because they're both on both sides. And so if you divide both sides by m, they both cancel out. Then all of a sudden we're looking for the minimum velocity, so let's go ahead and isolate this. So we bring the 2 over, so v squared is equal to 2gh. All of a sudden, to take a root of that, take a root of this, v is equal to root 2gh. That's the minimum speed that we have to have at the bottom to get to just get to the top. Okay?
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.